2018 question 6. Parts of the graph of the functions h of x equals x and k of x equals x cubed, where x is an element of the reals, are shown in the diagram below. We want to find the coordinates of the point of intersection of the graphs of the two functions. So h of x equals x, that's just the line y equals x, and k of x equals x cubed, that's just the cubic y equals x cubed. So if we want to find where they intersect, we can just equate these two functions. So we can just state x equals x cubed. So h of x equals k of x, that means x equals x cubed. So this means then if you bring the x over, you get x cubed minus x. If we factorize out an x, you're left with x on x squared minus 1. And if we solve this, then you're going to get x equals 0, or x squared minus 1 equals 0. So that means x squared minus 1 can be written as a difference of two squares as x minus 1 times x plus 1. So if we solve each of these factors, then you get x equals 0, x equals 1, or x equals minus 1. Now we want to find the coordinates. We have the x coordinates, we want to find the corresponding y coordinates. So we can use either h of x or k of x. So h of x would be easier to use. So this just states y equals x. So if x is 0, y is 0. Next of all, if x is 1, y is 1, and if x is minus 1, y is minus 1. So here we'd have the coordinates minus 1, minus 1. Here we've got 0, 0, and then up here we've got 1, 1. In B part 1 then, find the total area enclosed between the graphs of the two functions. So here we want to find area 1, that's bound between the cubic and the line, and area 2, that's also bound between the line and the cubic. Now for area 1, k of x is on top, h of x is on the bottom. So area 1 is going to equal the integral of k of x minus h of x. Now the x values go from minus 1 over to 0. So area 1 is going to be the integral from minus 1 to 0 of k of x minus h of x dx. So k of x is just x cubed minus h of x is just x. And the limits go from minus 1 up to 0. If you integrate x cubed, this gives x to the 4 over 4. If you integrate x, this gives x squared over 2. And then the limits go from minus 1 up to 0. If you put in 0 first of all, this just all equals 0. And then minus, if you put in minus 1, that's going to give a quarter minus a half. So a quarter minus a half is minus a quarter, and minus a quarter will change that to plus a quarter. Next of all, to calculate area 2 then. Now with area 2, the function h of x is on top. So in order to get a positive area, we're going to have h of x minus k of x. And the limits this time are going to go from 0 up to a plus 1. Now again, h of x was x, and then from that we're going to subtract x cubed. Now this would give us the same as before, except the other way around. So you're going to get x squared over 2 minus x to the 4 over 4. And this time the limits go from 0 to 1. If you put in 1, you get a half minus a quarter, which is just a quarter. So area 1 is a quarter, area 2 is a quarter, so the total area is area 1 plus area 2, and a quarter plus a quarter is just a half. So the total area is 0.5. Part 2 then, on the diagram on the previous page, using symmetry or otherwise, draw the graph of k inverse. That's the inverse of the function k. Now to find the inverse of a function, this is just a reflection in the line y equals x. So this line is the line y equals x. So what we have to do is just reflect the curve y equals x cubed in the line y equals x. So this part is just going to reflect around, and it goes like this. So that is k inverse.